Hi students, as you know, NDA has introduced a new unit in the chemistry syllabus for both the NEET and JEE from the year 2024 onwards. The new unit included is the principles related to practical chemistry. Since it is a newly introduced topic, the necessary study materials may not be available in print and visual media. But you need not worry. I am uploading video classes through my YouTube channel explaining the theory related to chemistry practical, which include a lot of multiple choice questions and their well explained answers. By the way, I am Dr. Siriak Matthew, a retired associate professor in chemistry. The purpose of my channel, Chemistry Master, is to upload video classes related to topics in chemistry within secondary, undergraduate, and postgraduate levels. At present, I am uploading video classes related to NEET, JEE Main and Advanced, and other entrance examinations. There will be a set of video classes for each chapter. In the present set of videos, we discuss the principles related to practical chemistry. This set includes 6 video classes. The first one, titled as Principles Related to Practical Chemistry, Part 1A, explained detection of extra elements and detection of functional groups. The second, titled as Principles Related to Practical Chemistry, Part 1B, contains multiple choice questions related to Part 1A. Part 2 explains preparation of some organic and inorganic compounds and a titrimetric analysis. Part 3, qualitative analysis for anions, and Part 4, qualitative analysis for cations. The Part 5 explains some physical chemistry experiments. At the end of each part, multiple choice questions related to that part are explained. Even if you go through a handbook of chemistry practical several times, you may not be able to remember the experiments and the theory behind it. But an audiovisual presentation will catch your attention. That is why I have introduced a lot of animations in these video classes so that you will get a feel of doing the experiments in the laboratory. However, animations never represent the real situation. And this is not an instruction manual for doing the experiments in the lab. The main purpose is to make you understand the theory behind the experiments. In the laboratory, you have to take several precautionary measures while doing the experiments. For your convenience, I have introduced video chapters or timestamps in the description part of the videos. This will help you to watch and rewatch separately the different topics explained in a particular video. The links for other videos are also given in the description part. You can easily move to any of these 6 videos using these links. I hope these video classes will definitely help you to understand the theory behind the experiments. If you like the video, please subscribe my channel and forward to others. You can expect similar video classes from other chapters of Class 11 and Class 12 Chemistry soon. Now we will discuss some of the multiple choice questions related to the topic that we have discussed. That is detection of extra elements, detection of functional groups. Question 1. In Lassane's test, the given organic compound is fused with a metal. The metal generally used is option 1, copper, option 2, sodium, 3, potassium, and 4, lithium. We have studied that the Lassane's extract is also called sodium extract or sodium fusion extract. Therefore, the metal used must be sodium. So we select option 2. That is the correct answer. But potassium can also be used for fusion of the organic compound. However, sodium is preferred because it is easily available and the reaction is more controllable compared to potassium. The second question is, in Lassane's test, sodium metal is preferentially used for fusing with organic compound since option 1, sodium is easily available and the reaction is controllable. 2, sodium has low melting point. 3, sodium forms ionizable salts when fused with organic compound. 4, sodium vigorously react with water. We may choose third option as the answer, but that is not the correct answer because potassium also forms ionizable salts when fused with the organic compound. So the correct answer is option 1. Sodium is easily available and the reaction is controllable. Third question. Lassane's test is used for identifying which of the following groups of elements. Option 1. Carbon, hydrogen and nitrogen. 2. Nitrogen, sulfur and arsenic. 3. Phosphorus, arsenic and halogens. 4. Nitrogen, sulfur and halogens. And Lassane's test is used for identifying extra elements. And we consider extra elements as nitrogen, sulfur and halogens. So option 4 is the correct answer. That also is the correct answer. Question 4. If an organic compound contains both nitrogen and sulfur, Lassane's test shows blood red coloration. This is due to the formation of option 1 thiocyanate ion, option 2 FeSCN2 plus, then 3 FeCN 5 times NOS, FeCN5NO. And the blood red color is due to the formation of ferric thiocyanate. So option 2 must be the answer. That is the correct answer. SCN is the thiocyanate ion and FeCN5NOS, sodium nitroprusside, that gives the Prussian blue color. And FeCN5NO is sodium nitroprusside. Fifth question. In the Lassane's test for nitrogen in an organic compound, Prussian blue color is obtained due to the formation of first option 1 Na4FeCN6, option 2 Fe4FeCN6 thrice, option 3 Na4FeCN 5 times NOS, option 4 NaFeFeCN6. And Prussian blue color is Fe4FeCN6, that is iron 2 hexacyanidoferrate. So option 2 must be the correct answer. That is cyanide ion plus ferrous ion, we get FeCN6 4 minus, and if sodium FeCN6 react with the ferric sulfate giving Fe4FeCN6 3 times, of course with the XH2, and this is the Prussian blue color. Question number 6. In which among the following compounds the presence of nitrogen cannot be detected by Lassane's method? 1. Hydrazine, 2. aniline, P. paratoluidine, 4. picric acid. All these compounds contain nitrogen. First, let us write down the structure of these compounds. This is hydrazine, aniline, paratoluidine, and picric acid. All these compounds contain nitrogen. But in the case of Lassane's test, when we fuse the compound with the sodium, sodium cyanide is formed. That means sodium plus carbon plus nitrogen, that gives sodium cyanide. But in the case of hydrazine, there is no carbon atom. So therefore, when we fuse hydrazine with sodium, sodium cyanide may not be formed, and so it will not answer the Lassane's test. So the option must be hydrazine. That is the correct answer. Hydrazine does not contain carbon, so no cyanide ion will be produced. Question 7. Match the color in list 1 with the compound or ions given in the list 2. List 1, blood red, Prussian blue, violet, black. List 2, lead sulfide, FeCnNOS, Fe for FeCn 6 times thrice, FeSCn 2 plus. The options given are 1 A to 3, B to 4, C to 2, D to 1. Option 2, option 3 and option 4. And we know that the blood red color is due to the ferric thiocyanate. So A in list 1 match with the 4 in the list 2. Similarly, Prussian blue is Fe for FeCn 6 thrice. So B to 3, and violet color is due to thionitroprusside, and we know the black color is due to lead sulfide. So option 4 must be the correct answer. Yes, that is the correct answer. Question 8. An organic compound contains nitrogen and sulfur. For preparing Lassane's extract, it is fused with excess of metallic sodium and tested for nitrogen. The color observed will be blood red, Prussian blue, black, and violet. Since nitrogen and sulfur are present, we expect blood red color. This is due to the formation of ferric thiocyanate. But we are fusing with the excess of metallic sodium. So when fused with the excess of metallic sodium, the thiocyanate will be decomposed. Since sulfur is also there, a black precipitate of ferrous sulfate will be formed when we add ferrous sulfate to the solution. So therefore, when we boil the Lassane's extract and acidify with the sulfuric acid, ferrous sulfate will dissolve, and thus Prussian blue color will appear. So the answer must be the second option, and that is the correct answer. So sodium thiocyanate, if you use excess sodium, it decomposes to sodium cyanide and sodium sulfide. When we test for nitrogen, at first we get a black precipitate of ferrous sulfide, but when we boil with the dilute sulfuric acid, ferrous sulfide dissolves and the Prussian blue color appears. Question 9. While detecting sulfur using Lassane's extract, a black precipitate is obtained. This is due to the formation of 1. Lead sulfide, 2. Sodium sulfide, 3. Sodium thiocyanate, 4. Lead acetate. When fused with the sodium, we know sulfur will be converted to sodium sulfide. When lead acetate is added to the solution, it produces lead sulfide, and lead sulfide is having a black color. So the answer should be option 1. That is the correct answer. That is sodium sulfide, and this is lead acetate, and lead sulfide is black in color. Next is an assertion reason question. Assertion: for testing nitrogen, the lysines extract should be boiled gently after the addition of ferrous sulfate. The reason: excessive boiling may cause total conversion of ferrous iron to ferric iron, and a Prussian blue color may not be obtained. Option 1. Both assertion and reason are correct, and a reason is the correct explanation of the assertion. Both assertion and reason are correct, but reason is not the correct explanation of the assertion. Third one, assertion is correct, but reason is incorrect. Both assertion and reason are incorrect. In lysines extract for testing nitrogen, ferrous iron should be there. If ferrous iron is not present, hexacyanidoferrate 2 will not be formed. So therefore, the iron 2 hexacyanidoferrate also will not be formed, and no Prussian blue color may appear. So the assertion is correct, and a reason also is correct, and a reason explains assertion. So we can choose option 1. That is the correct answer. Question 11. Layer test used to distinguish between 1. Primary, secondary and tertiary alcohols, primary, secondary and tertiary amines, chloride, bromide and iodide, primary, secondary and tertiary haloalkanes. Layer test is used to distinguish between chloride, bromide and iodine. Chlorine displaces bromine from aqueous solution. Similarly, chlorine can displace iodine from aqueous solution also. So the option 3 must be the correct answer. That is the correct answer. Question 12, that again is an assertion reason question. If an organic compound contains nitrogen and sulfur along with the halogens, the extract should be boiled with concentrated nitric acid before testing for halogens. Reason: nitrogen and sulfur will interfere with silver nitrate test for halogens. The options are both assertion and reason are correct, and a reason is the correct explanation of assertion. Both assertion and reason are correct, but reason is not the correct explanation for assertion. Assertion is correct, but reason is incorrect. Both assertion and reason are incorrect. If nitrogen and sulfur are present in an organic compound, they will be converted to cyanide and sulfide ions. When silver is added, this cyanide will be precipitated as silver cyanide, which is white in color, and a sulfide will be precipitated as silver sulfide, which is black in color. Therefore, this will interfere with the silver nitrate test. So, assertion is correct, and a reason also is correct, and a reason explains the assertion. So, we go for option 1. And option 1 is the correct answer. Question 13. When fused with metallic sodium, sulfur is, if present in the organic compound, will be converted to sodium sulfide. The presence of sodium sulfide could be detected using 1. Na2FeCN5NO, Na4FeCN5 NOS, CH3COO twice Pb. So option 1 is 1, 2 and 3. Option 2, 1 and 3 only. Option 3, 2 and 3. Option 4, 3 only. We know sodium sulfide, it reacts with Na2FeCN5NO, sodium nitroprusside, gives a purple violet color of sodium thionitroprusside. So we can use sodium nitroprusside for testing sulfur. Similarly, when we add lead acetate solution and it produces a black precipitate of lead sulfide. So these two reagents can be used for detecting the presence of sulfur. So the answer must be 1 and 2, second option. That is the correct answer. Question number 14. Lucas reagent contains 1 zinc chloride and dilute HCl, zinc chloride and concentrated HCl, zinc chloride and concentrated sulfuric acid, copper and concentrated HCl. And we know that Lucas reagent contains zinc chloride and concentrated hydrochloric acid. So option 2 must be the answer. That is the correct answer. Question 15. Conversion of ethanol to ethanol is an example of oxidation, hydrolysis, reduction, rearrangement. And we know that it is oxidation. So option 1 is the correct answer. Question 16. The alcohol which produces turbidity immediately with a Lucas reagent at room temperature is option 1, butane 1-ol, butane 2-ol, 2-methyl propane 2-ol, 2-methyl propane 1-ol. So to identify the compound, first it is better to write down the structures of this compound. And this is butane 1-ol, and this one is 2-methyl propane 2-ol, butane 2-ol, 2-methyl propane 1-ol. And we know that this is a tertiary alcohol. So this will give turbidity immediately with the Lucas reagent. So 2-methyl propane 2-ol will give turbidity immediately. So we go for option 3, that is the correct answer. Question 17. The following compounds can be distinguished by which of the reagents given below? So compound 1 and compound 2. Neutral ferric chloride solution, iodophone test, both option 1 and option 2, and fourth option is 2,4-dinitrophenylhydrazine. And the first one is a phenol and the second one is an alcohol. So we can use neutral ferric chloride for identification of the first compound. And with a neutral ferric chloride, the phenolic compound 1 will give a violet color, while the alcohol 2 will not give. So we can distinguish between these two using neutral ferric chloride. Similarly, the alcohol 2 will give positive iodophone test because it contains CHOHCH3. So therefore, the phenol will not give iodophone test. So we can use both a neutral ferric chloride solution and iodophone test for distinguishing between these two compounds. So option 3 could be taken as the answer. That is the correct answer. Which of the following compounds will give positive iodophone test? Option 1, C6H5CS2CS2OH. Option 2, option 3, and option 4. Here, iodophone test is given by compounds which contain CH3CHOH grouping. So option 3 contains CH3CHOH grouping. So option 3 will give iodophone test. That is, when we treat it with the iodine and sodium hydroxide, it is oxidized to ketone, and further it is converted to iodoform. So option 3 should be the answer. That is the correct answer. Question 19. What is the correct order of reactivity of alcohols in the following reaction? ROH plus HCl in presence of zinc chloride, RCl plus H2O. Option 1, primary greater than secondary greater than tertiary, primary greater than secondary less than tertiary, tertiary greater than primary greater than secondary, tertiary greater than secondary greater than primary. And we know that zinc chloride and HCl is the Lucas reagent. And the order of reactivity for Lucas reagent is the fourth option, tertiary greater than secondary greater than primary. So option 3 is correct. Option 4 is correct. Yes, that is the correct answer. Because of the order of stability of the respective carbocations. Question number 20. Which of the following compounds is most acidic in nature? A, B, C, and D. Option A, option 2, B, option 3, C, option 4, D. And the stability or the acidic nature depends on the stability of the negative ion after the removal of the H plus ion. So among this, when we take phenol, after the removal of H plus ion, the phenoxide ion is stabilized by resonance. So the negative ion is stabilized by resonance. Hence, compound D will be most acidic in nature. That is the correct answer. Question 21, an assertion reason question. Phenol is soluble in sodium hydroxide solution, but not soluble in sodium hydrogen carbonate solution. Reason, phenols are more acidic than alcohols. Option 1, both assertion and reason are correct, and a reason is the correct explanation of assertion. Both assertion and reason are correct, but reason is not the correct explanation of assertion. Assertion is incorrect and reason is correct. Both assertion and reason are incorrect. And assertion is correct. Phenol is soluble in sodium hydroxide solution, but not soluble in sodium bicarbonate solution. And this is because phenol is not acidic enough to dissolve in sodium hydrogen carbonate. Reason phenols are more acidic than alcohol. The reason is correct. But reason is not the correct explanation of the assertion. So we choose option 2. That is the correct answer. Phenols are weakly acidic, so they are soluble in sodium hydroxide. But they are not sufficiently acidic to be soluble in sodium hydrogen carbonate. Question 22. What reagents can be used to convert ethanol to triiodoacetaldehyde or triiodoethanol? Option 1, Ki and KOH, Ki and NaCl, chlorine water, potassium iodide and sodium hypochlorite. So option 4 is the correct answer. Sodium hypochlorite first oxidizes potassium iodide to potassium hypoiodide, which oxidizes ethanol to acetaldehyde and then to triiodoacetaldehyde. Question 23. Assertion CH3OH and CH3CH2OH cannot be distinguished by iodophone test. Reason ethanol and secondary alcohols which contain CH3CHOH groups can give positive iodophone test. Both assertion and reason are correct, and reason is the correct explanation of assertion. Both assertion and reason are correct, but reason is not the correct explanation of the assertion. Assertion is correct, but reason is incorrect. Assertion is incorrect, but reason is correct. And we know that this is methanol and this is ethanol. And ethanol answers iodophone test. So we can distinguish between methanol and ethanol using iodophone test. So assertion is wrong. Then ethanol and secondary alcohols which contain CH3CHOH R groups can give positive iodophone test. Reason is correct. So option 4 is correct. Assertion is incorrect, but reason is correct. And that is the correct answer. Question 24. Ethanol can be distinguished by iodophone test. Then a reason iodophone test is given by secondary alcohols. Option 1, option 2, option 3 and option 4. Here ethanol can be distinguished by iodophone test. That is correct. Iodophone test is given by secondary alcohols. That also may be correct, but that is not the explanation for the assertion. So we choose option 2. That is the correct answer. Iodophone test is used to identify alcohols or carbonyl compounds. The alcohols containing CH3CHOH group linked to carbon or hydrogen atom can be distinguished from other alcohols using iodophone test. Thus, ethanol gives positive iodophone test. Question number 25, statement 1. Lucas test can be used to distinguish between primary, secondary, and tertiary alcohols of any type. Statement 2. The alcohols used in Lucas test must be soluble in Lucas reagent. Both statements 1 and 2 are correct. Both statements 1 and 2 are incorrect. Statement 1 is correct. Statement 2 is incorrect. Statement 1 is incorrect. Statement 2 is correct. Now, one basic requirement to use the Lucas reagent is that the alcohol must be soluble in Lucas reagent. Otherwise, turbidity will appear on addition of Lucas reagent. So, Lucas reagent or Lucas test is applicable to only those alcohols which are soluble in the reagent, because the test is based on the separation of alkyl halides or separate layer. So the first statement may not be correct. That is, Lucas test can be used to distinguish between primary, secondary, and tertiary alcohols of any type. So we can use alcohols those are soluble in Lucas reagent could be used for distinguishing between primary, secondary, and tertiary alcohol. So statement 1 is incorrect, but statement 2 is correct. So we go for option 4, and that is the correct answer. Question 26. Statement 1. Phenol is more acidic than ethanol. Statement 2. Phenoxide ion is stabilized by resonance. The options are 1, 2, 3, and 4. And we know that phenol is more acidic than ethanol. So the statement 1 is correct. Also, we know phenoxide ion is stabilized by resonance. So the first option is the correct answer. Question number 27. Phenol gives a colored complex with neutral ferric chloride. The color of the complex is 1 blue, 2 red, 3 violet, and 4 pink. We have studied that the color is violet. So that is the correct answer. That is phenol ferric chloride. We get this compound. The color of this compound is violet. Question 28. In thiolin dye test, phenol is condensed with X in presence of concentrated sulfuric acid. The compound X is option 1 acetic anhydride, option 2 benzoyl chloride, option 3 phthalic anhydride, option 4 phthalic acid. So phenol condenses with phthalic anhydride, giving phenolphthalein. So option 3 is the correct answer. So the reaction is phenol plus phthalic anhydride. We get this compound, and this is the pink colored compound, and that pink color occurs in the pH range of 8.3 to 10. If you add excess of sodium hydroxide, it becomes colorless. Question number 29. Assertion. In thiolin dye test, pink color of phenolphthalein disappears when excess sodium hydroxide is added. Reason: at pH higher than 12, phenolphthalein becomes colorless. Options 1, option 2, option 3, option 4. And we know that if you add excess sodium hydroxide, the color of phenolphthalein disappears. And therefore assertion 1 is true. And the reason is at pH higher than 12, phenolphthalein becomes colorless. So option 1 is the correct answer. So when you add excess sodium hydroxide, the pH increases so that pH is greater than 12. So phenolphthalein shows pink color in the pH range of 8.3 to 10. Question number 30. Which of the following compound will not dissolve in sodium hydrogen carbonate? 1, 2,4,6 trinitrophenol, 2,4-dinitrophenol, 3 benzoic acid, 4 phenol. Phenols like 2,4,6 trinitrophenol and 2,4-dinitrophenol, which contain electron withdrawing groups. Because of that, they are strong acids and dissolve even in sodium hydrogen carbonate solution. So the first two will dissolve in sodium carbonate, sodium bicarbonate, and benzoic acid also being an acid, it dissolves in sodium bicarbonate or sodium hydrogen carbonate, and only phenol is insoluble. So the correct option is 4. That is the correct answer. So these two compounds can be distinguished by iodophone test because this will not contain CH3CO grouping. So this contains CH3CO grouping. So we go for option 3, that is the correct answer. The Bayer's test is a test for unsaturation. Alkenes dechlorize the neutral or alkaline potassium permanganate solution and vicinal glycols are formed. So Bayer's test is used for testing the unsaturation. 32. Iodophone can be prepared from all except butane 2-on, propane 2-ol, 3-methyl butane 2-on, 2-methyl propane 1-ol. And let us see the structure of this compound. So this is butane 2-on and propane 2-ol, and this is 3-methyl butane 2-on, and this is 2-methyl propane 1-ol. And here we have CH3CO grouping. Here also we can have CH3CHO part is there. And here also CH3CO grouping. So these three compounds will give iodophone test. But here 2-methyl propane 1-ol will not give iodophone test. So the answer is 2-methyl propane 1-ol. Question number 33. Failing solution is ammoniacal silver nitrate solution, alkaline solution of cupric ions complexed with the tartrate ions, alkaline solution of copper 2 ions complexed with the citrate ions, alkaline KMnO4 solution. And we know failing solution is alkaline solution of cupric ions complexed with the tartrate. So the answer must be there. Choose the reagent which is unfit among the following group. Tolerance reagent, alkaline KMnO4, failing solution, and Benedict's reagent. All except alkaline KMnO4 are mild oxidizing agent. So the answer is option 2, alkaline KMnO4. Benedict's solution is 1. Ammoniacal silver nitrate solution, 2. Alkaline solution of cupric ions complex with the tartrate ions, alkaline solution of cupric ions complex with the citrate ions, alkaline KMnO4 solution. Benedict's solution is alkaline solution of cupric ions complex with the citrate ions. And option 2 is alkaline solution of cupric ions complex with the tartrate, and that is the filling solution. When ethanol is treated with the filling solution, it gives a red precipitate of copper, cupric oxide, cuprous oxide, Cu2 1O, cupric oxide and a cuprous oxide. And the red precipitate is due to the presence of Cu2 1O or cuprous oxide. That is the correct answer. Then statement 1, filling solution is 1:1 mixture of filling solution A and a filling solution B. Statement 2, filling solution A is aqueous copper sulfate solution and a filling solution B is alkaline solution of sodium citrate. Then both statement 1 and 2 are correct. Both statements 1 and 2 are incorrect. Statement 1 is correct. Statement 2 is incorrect. Statement 1 is incorrect. Statement 2 is correct. Filling solution is a 1:1 mixture of filling solution A and filling solution B. So statement 1 is a correct statement. Filling solution A is aqueous copper sulfate solution and a filling solution B is alkaline solution of sodium citrate. That is incorrect. It is tartrate. So therefore option 3 is correct, statement 1 is correct and statement 2 is incorrect. That is the correct answer. Which of the following will be produced when benzaldehyde is treated with the filling solution? 1. Cu plus ions, Cu2 plus ions, C6H5CO minus ion, and fourth one, no reaction. And aromatic aldehydes do not react with the filling solution. So they do not give positive filling test. So option 4 is correct. Which of the following test is answered by both aldehydes and ketones? Schiff's test, Filling's test, 2,4-dinitrophenyl hydrazine test, Tollens test. So 2,4-dinitrophenyl hydrazine test is answered by both aldehydes and ketones. So option 3 is the correct answer. Which of the following compounds will not give silver mirror test? 1. Acetone, benzaldehyde, acetaldehyde, methanol. And a silver mirror test is given by aldehydes. So the answer should be acetone. But we here the fourth option is methanol. So just look for methanol. That is the wrong answer. So the correct answer is acetone. Acetone being a ketone will not answer the silver mirror test. It is given by aldehydes such as acetaldehyde and benzaldehyde. But alcohols that can be easily oxidized to aldehydes, for example methanol, also answer silver mirror test. So these second, third and fourth option will give silver mirror test. Only acetone will not give silver mirror test. Aldehydes and ketones can be distinguished by 1. Ammonia, 2. Sulfuric acid, 3. Alkaline KMNO4, 4. Filling solution. So ketones will not answer filling test. So option 4 is the correct one. Which of the following pairs can be distinguished using tolerance reagent? Ethanol and propanol, propanoic acid and propanol, ethanoic acid and ethanol, methanoic acid and propanol. But which of the following pairs can be distinguished using tolerance reagent? And a tolerance test is answered by ethanol. So we can distinguish ethanoic acid and ethanol using tolerance reagent. That is the correct answer. Compounds given in option 1, 2 and 4 do not react with the tolerance reagent. But in option 3, ethanoic acid do not react with the tolerance reagent, but ethanol does. So we can distinguish ethanoic acid and ethanol using tolerance test. Which of the following organic compounds answer both iodophone test and Felling's test? Methanol, ethanol, propane, ethanol. So ethanol will give both iodophone test and a Felling test. So iodophone test is given by those compounds which contain CH3CO group or CH3CHOH group, while Felling's test is given by aldehyde. So ethanol gives both the test. So that is the correct answer. Statement 1. Presence of carboxylic acid can be confirmed by litmus test, where blue litmus is turned red. Statement 2. If the color of blue litmus changes to red, the presence of either a carboxyl group or a phenolic group is indicated. Both statements 1 and 2 are true. Both statements 1 and 2 are false. Statement 1 is true, but 2 is false. Statement 1 is false, but 2 is true. Presence of carboxylic acid can be confirmed by litmus test. But we cannot use this as a confirmatory test for carboxylic acid because phenols also turns blue litmus red. So statement 1 is not correct. So statement 2 is correct. If the color of the blue litmus changes to red, the presence of either a carboxyl group or a phenolic group is indicated. So that is the correct option. Question 45. Which of the following tests can be used to distinguish between phenol and benzoic acid? Litmus test, tolerance test, sodium hydrogen carbonate test, aqueous sodium hydroxide test. And these two can be distinguished by sodium hydrogen carbonate. Phenol is not acidic enough to react with the sodium hydrogen carbonate. Which of the following statement is incorrect? 2,4-dinitrophenylhydrazine test can distinguish ethanol and acetone. Iodophone test can distinguish acetone and propanol. Lucas test can distinguish propan 1-ol and propan 2-ol. Sodium bicarbonate can be used to distinguish phenol and benzoic acid. And option 1 is the answer because 2,4-dinitrophenyl test can distinguish ethanol and acetone. Both ethanol and acetone answer 2,4-dinitrophenylhydrazine test. So the answer should be this one. That is the correct answer. Match compounds in list 1 with those in list 2. List 1 acetic acid, phenol, CH3CH2CHO, CH3CHOH, CH2CH3. Then potassium iodide, sodium hypochlorite, sodium hydrogen carbonate, phthalic anhydride, para-rosanilin hydrochloride, and sodium sulfite. So option 1, option 2, option 3, and option 4. Then acetic acid, and since it is a carboxylic acid, it will give, it dissolves in sodium bicarbonate, liberating carbon dioxide. So we can connect A to 2. Then phenol, and we know that phenol combines with the phthalic anhydride. That is the thiolin test. So B2, 3. And C is CH3CH2CHO, and that is an aldehyde, and para-rosanil hydrochloride is Schiff's reagent. So C2, 4. And this compound contains CH3CHOH grouping. So it will answer the iodophone test. And the reagent for iodophone test is potassium iodide and sodium hypochlorite. So option 1 is correct. That is the correct answer. Carboxylic acid does not form iodoform because the resonance in the carbonyl group prevent efficient removal of acidic hydrogen by the hydroxide ion during the test. Even though this acetic acid contains CH3CO grouping, it will not give iodophone test. Question 48. In the following reaction, the product B should be destroyed as soon as it is formed. What are A and B? So A reacting with the chloroform and potassium hydroxide, B is produced. And option 1, A is C6H5NaCH3, B is C6H5NC. Option 2, A is C6H5NS2, B is C6H5CN. And 3, this one. And 4, A is CH3NS2, B CH3CN. And we know that the product that should be destroyed is carbylamine. And the carbylamine test is given by primary amine. So this is not a primary amine. And this is primary amine, but B is not isocyanide. This is cyanide. And here it is a primary amine, and this is carbylamine. So option 3 can be taken as the answer. So that is the correct answer. That is primary amine, aromatic or aliphatic primary amine, reacts with the chloroform in presence of alcoholic potassium hydroxide, gives carbylamine. Carbylamine so formed is highly toxic and should be destroyed immediately after the test. And for that, we cool the test tube and add carefully an excess of concentrated hydrochloric acid. Question 49. Ethylamine and diethylamine can be distinguished by carbylamine test. Statement 2. Aliphatic and aromatic primary amines on heating with chloroform and ethanolic KOH produce carbylamines, which are foul-smelling substances. And answers are both statements 1 and 2 are correct. Both statements 1 and 2 are incorrect. Statement 1 is correct but 2 is incorrect. Statement 1 is incorrect but 2 is correct. Ethylamine and diethylamine can be distinguished by carbylamine. That statement is correct. That means ethylamine is a primary amine and only primary amine forms carbylamine test. So both statements 1 and 2 are correct. So option 1 is the correct option. Only primary amines form carbylamine. Diethylamine is a secondary amine. Which of the following is the weakest Bronsted base? A, B, C and D. Option 1 A and C, option 2 B only, option 3 D only, option 4 A only. And all contain nitrogen atoms and they act as a Bronsted base because of the presence of lone pair of electrons. In aniline, the lone pair is not available because it is given to the benzene ring for resonance. So the weakest Bronsted base should be compound A. So that is the correct answer. The lone pair on nitrogen is not available in aniline due to resonance with benzene ring. Question 51. Which of the following amines will give carbylamine test? A, B, C and D. Option 1 A and B. Option 2 C only. Option 3 D only. Option 4 B only. And we know that carbylamine test is given by primary amines only. And here D is the primary amine. So answer should be D and that is the correct answer. Aniline and ethylamine can be distinguished by A. Carbylamine test, B. Solubility test, 3. Azodite test and 4. Litmus test. And we know that aniline forms an azodite. So therefore we can use option 3, that is azodite test, to distinguish between aniline and ethylamine. So aniline first forms benzene diazonin chloride and it couples with the beta naphthol, giving a scarlet red azodite, beta naphthol azodite. So option 3 is the correct answer. 53. Diazotization of aniline can be used for its identification reaction. Reason: diazonin salt of aniline forms various colored azodides through coupling reaction with suitable reagents. Both assertion and reason are correct. Reason is the correct explanation for assertion. Option 2, option 3. Here assertion is correct. Diazotization of aniline can be used for its identification, that is formation of azodite. Reason: diazonin salt of aniline forms various colored azodides through coupling with suitable reagents. So both assertion and reason are correct, and reason is the correct explanation of assertion. So we choose option 1 and that is the correct answer. Diazonium salts undergo coupling reaction with the beta and aphthol to give colored dye. This reaction can be used for identification of aniline. Question 54. The most reactive amine towards dilute hydrochloric acid is CH3NH2, CH3 twice NH, CH3 thrice N, C6H5NH2. So we may opt for CH3 thrice N. So to be reactive towards dilute hydrochloric acid, it should be the most basic one. And we expect this be the most basic one, but that is not the correct answer. To find out the answer, we have to check the structure of these compounds first. This is CH3NH2, CH3 twice NH, CH3 thrice N, and aniline. In all these cases, nitrogen contains lone pair of electrons. The basic character depends on the availability of lone pair on nitrogen. Compound 2 is more basic compared to 1 because of the electron donating tendency of the methyl group. Here there is only one methyl group. Here there are two methyl groups. But 3 is less basic than 2. We expect 3 to be more basic compared to 2 because there are 3 methyl groups. But that is not the correct answer. This is because of the steric effect. The steric effect of 3 methyl group hinders the availability of lone pairs on nitrogen. In aniline is least basic because the lone pair is taken into the ring for resonance. So the correct answer is the second one. Now the last question. The correct increasing order of basic strength of the following compounds is compounds 1, 2 and 3. Option 1, option 2, option 3, option 4. And we know that aniline, the lone pair will be withdrawn to the ring. And here NO2 group is electron withdrawing group. So therefore, compound 2 will be less basic than compound 1. And here it is CH3 grouping. So that is electron donating group. So among these 3 will be most basic. So least basic should be second one, then comes the first one, and then comes the third one. So that is the correct. So option 4 is the correct order.